So in this session, we will do the structure question related to topic measuring the mass, weight, and density. In the first question, figure 3.1 shows an oil tank that has a rectangular dimensions which are 2.4 meter multiplied by 1 or by 1.5. So one of the side is 2.4, another side is 1.5, and height is also 1.5. The tank is filled with oil and which is having a density of 850 kilogram per meter cube at a depth of 1.5. So when the depth is 1.5, the and the density of the oil is 850, we have to calculate the mass of the oil. So how we can calculate the mass of the oil? We have the formula that density is equals to mass present in a unit volume. So mass divided by volume, that is density, but in the question we need mass, so the mass will be equal to density multiplied by the volume. So what is the density of the oil as we are finding the mass of the oil? So the density of the oil is given 850. So this will be 850. And what about the volume? So we can say in terms of symbol, we can say the mass is equals to density represented by a Greek alphabet rho multiplied by volume. And what about the volume? Volume is length, width, and height. So when we multiply these three sides, what we'll get? We'll get the volume of the oil inside this rectangular tank. So to get the volume, we'll multiply 2.4 into 1.5 into 1.5. So this whole will be the volume and 850 is the density. So when we multiply, what's the answer? 850 multiplied by 2.4 into 1.5 and 1.5. What is the final answer? 4,590. So the mass of the oil which is inside, that is 4,950, and because the density is kilogram per meter cube, so mass will be in kilogram. Is it clear? This first part, question 1 part A. Is it clear to everyone? The first part. In the second part, they say when he's checking the level of the oil in the tank, a man drops a brass key. So a key is there which is made up of a brass into the oil and it sinks to the bottom. What we can say about the density of the brass? Like what happened by mistake, a man working in the tank, he drops a key or the key is dropped from him and it moved to the bottom of the pond or it moved downward. So what we can say about the density of this key or density of the brass? What we can say about the density of this key or density of the brass key? Is it more than oil or less than oil? So density, yeah, that's right. It is greater than the oil density. That's why it sinks. So in the question they ask, when he's checking the level of the oil in a tank, a man drops a brass key and it sinks into a bottom. State what this show about density of the brass. So it shows that density of the brass is more than or greater than the density of oil. Then the third part, explain how attaching the key with a piece of wood would prevent the key from sinking. So what would happen, like example, if we have a key here and we attach a piece of wood to this key. So what we observe, when we attach a piece of wood to this key, it does not sink. So what we can say about, as the piece of wood attached to the key, it does not sink. Actually, both of them are floating together. So what we can say the combined density of wood and brass key is less than density of the oil. That is why the key float with a piece of wood. Is it clear? The combined density, like example, if you are in the ship, why you are floating when you are in the ship and you sink if you are not on the ship? So that is the combined density. The combined density of ship and you is less than the density of the water. That's why you float. So if you change the density, we can change the floating or sinking. So when a key is placed with a piece of wood, so the combined density, the total density of the key and the wood is less than the density of the oil. That's why it is floating. Combine, because Abdullah, what happened, it's not like, because the volume is also increasing, the formula for density, the density is mass present in unit volume. So the total, when key is joined with a piece of wood, the mass will also increase and the volume will also increase, but increase in mass will be small, but increase in volume will be greater. As the volume increases greater, the density will decrease. I will give you an example. Say the mass of the key was 2 kilogram, okay, and the volume of the key, this is just an example, say 1 meter cube. So what is the density of the key right now? So density of the key, density is mass present in a unit volume. So mass is equals to 2 and the volume is 1, so 2 divided by 1, so it will be 2 kilogram per meter cube. That's a combined density. That's not a combined, that's a density of a key. Same thing if I say what is the density of the wood. So mass of the wood, so mass of the wood, example, the mass of the wood is 2 kilogram and the volume of the wood, but because wood is having low density, so its volume will be higher. Example, it is 10. So when we find the density of the wood, so density of a wood, mass divided by volume, so mass is 2 and the volume is 10, so 2 divided, so that is equals to 0.2 kilogram per meter cube. But now if we find, so this is the density of the wood and this is the density of key. But if we are finding the combined density of the wood and the key, so when we find the combined density, how to find the combined density? That is the combined mass. So the combined mass, the mass of the key is 2 and the mass of the wood is also 2. So 2 plus 2, 4. But what about the volume in contact? Because when you place a piece of wood, so actually wood is in contact with a liquid. So when we find the total volume, so total volume, this is one is there for the key and 10 is there for the wood. So 10 plus 1, that make 11. So it will be 4 divided by, 11 and 4 divided by 11. So what it is coming out? It is coming out as 0.36 kilogram per meter cube. So you can clearly see the combined density is less than the density of the brass. Originally the density of was 2. For simply when there was a key, the density was 2. But when we work out the combined density, it is coming out less than the density of the key. That's why when a piece of wood is attached to a key, it is floating on the oil surface. Is it clear? This idea about floating. So the combined density can change depending on what is the change in the mass and what is the change in volume. Is it clear to everyone? Any question or a doubt in this part? As it was, the question was there in second B part 2, they mentioned that explain how attaching the key to a piece of wood could prevent the key from sinking. So how it will prevent key from sinking? That when a key is attached with a piece of wood, their combined density or total density is less than the density of the oil. That is why they are floating. Like it's a very common example. The life jacket, actually how the life jacket worked, the same idea. The life jacket, in case of emergency, when a person is using a life jacket or a person is not able to swim, he can also use the life jacket. So what happened? The mass of the life jacket is very small because it negligible because it is filled with air, and its volume is more, so the combined or the density will decrease. That's why when a person is wearing a life jacket, likely he will float on the surface of water. Moving on to the next question. In figure shows a remote sensing equipment. So there's a, like when we want to identify or investigate or gather information from different planets, so we send a remote sensing equipment on the surface of a distant planet. Like there's a planet which is far away from us and we send this equipment. The mass of the equipment is 350. So the equipment mass is 350. The acceleration of a free fall on the surface of the planet is 7.6. What is meant by the term weight? So what is the definition of the weight? How we define a weight? So weight is refers to the force of the gravity, the gravitational pull, or we can say force or pull of the gravity acting on the object. That's the best definition for the weight. So pull of gravity acting on the object. Then calculate the weight of the equipment on the planet. So they mention acceleration of a free fall. The gravity is also known as acceleration of a free fall. So acceleration of a free fall or value of the gravity is 7.5. So G is equals to 7.5. It can be Newton per kilogram or it can be meter per second square. Both units can be used for gravity. Commonly we use Newton per kilogram, but meter per second square can also be used, which is same as a unit of acceleration. The mass of the equipment is 350. So this is the mass of the equipment. We need the weight. So the formula which relate the weight and the mass together. So weight is equals to mass multiplied by gravity. The mass of the equipment, that is 350, and the weight of the and the gravity is 7.5. So 350 multiplied by 7.5. What is the weight of the equipment on the planet? 350 multiplied by 7.5. 2625 Newton. So this is 2625 Newton. Is it clear? The second part. A part 1 and 2. The next part, so what happened, the equipment releases a balloon from a point that is a small distance above the surface. Like this is the surface of the planet, and the equipment releases the balloon here from the surface. The question, the atmosphere at the surface of this planet has a density of 0.35 kilogram per meter cube. So density of the surrounding, or density of the fluid, is 0.35 kilogram per meter cube. The inflated balloon has a mass of 80 grams. So mass of this balloon is 80 gram and its volume is 0.3. So its volume is 0.3 meter cube. Make an appropriate calculation, then predict and explain the direction of the motion. How we can predict the direction of the motion? First, we'll find the density of the balloon. If the density of this balloon is less than the density of the surrounding air or atmosphere, then what will happen? This balloon will rise. But if the density of the balloon is more than the density of the surrounding air, so it will sink. So first what we do, we'll find the density of the balloon, and to get the density of the balloon, we should get the mass, because density is mass present in a unit volume. Keep in mind, if the mass is given in, as you can see, the atmosphere density is kilogram per meter cube. So when we are comparing the two values, we should also have the same unit. So if atmosphere density is kilogram per meter cube, so the balloon density should be in kilogram per meter cube as well. So mass here is given 80 gram. So mass of the balloon is given 80 gram. So I have to convert into kilogram. So how I'll convert the gram into kilogram? So when we want to convert gram into kilogram, we'll divide by 1000. So 80 divided by 1000, so it will come out as 0.08 kg. And the volume is already given in meter cube, so we don't have to convert. It is written 0.30 meter cube. Now to get the density of the balloon, the density of a balloon, that is mass is 0.08 and volume is 0.3. So 0.08 divided by 0.3. What's the answer for density in kilogram per meter cube? 0.08 divided by 0.3. What's the answer? 0.26. So that's equal to 0.26 kilogram per meter cube. So the density of the balloon is 0.26 and density of the surrounding air is 0.35. So what will happen to this balloon? Will it float or sink, or it will move upward or downward? The density of the balloon is 0.26 kilogram per meter cube. The density of the balloon is less than the density of the atmosphere. That's why this balloon will rise, or it will move upward. And what is the reason for that? Because the density of the balloon is less than density of surrounding atmosphere. That is why, like example, if I have two balloons, one is filled with carbon dioxide, another will filled with helium. When I release the balloon which is filled with carbon dioxide, that will move down. If I release a balloon which is filled with a helium gas, that dries up. So why the two balloons, even if they have the same volume, one rises, another one fall or move downward? That is because if the carbon dioxide, as the carbon dioxide density is higher than the atmospheric density, so it will sink. but density of the helium is less than the density of the surrounding. That's why it will rise. Is it clear? The second part, part B, the calculation and explanation of part B. Anyone having a doubt in this part? Look, what happened in the question, they mentioned that there's a equipment as it is shown in the previous part that releases a balloon. So a balloon is released and that is a small distance above the surface of the planet. The atmosphere at the surface of this planet has a density of 0.35. So the density of this whole atmosphere on the planet, this is the density of the planet, which is 0.35. And in this planet, we release a balloon which is having a mass of 80 gram and the volume is 0.3. So basically how we can predict whether the balloon will rise or it will sink or fall depending on the density of the balloon. So we will find the density of the balloon, and when we are finding the density of a balloon, we should have in the same unit as density of atmosphere so that we can compare the two values. So density of the atmosphere is given in kilogram per meter cube. So the density of balloon should be in kilogram per meter cube as well. The mass here is given 80 gram. So when we convert the mass into kilogram, we divide by 1000. So 80 divided by 1000, that's equal to 0.08. And volume is already given in meter cube, so we don't have to convert the volume. So mass divided by volume, the mass is 0.08 and the volume is 0.30 or 0.3. So we get the density of the balloon, which is 0.26. So density of the balloon is 0.26 kilogram per meter cube, where the density of the atmosphere is higher as compared to that of balloon. So whenever object density is less than the surrounding density, what we observe? We observe that object will rise. Is it clear, Hatim? Another question. A block of wood has a volume of 210 centimeter cube and the mass of 180. Keep in mind when you are finding the density, because the unit of the density is gram per centimeter cube or kilogram per meter cube. So if mass is in gram, volume should be in centimeter cube. If mass is in kilogram, the volume should be in meter cube. So here the mass is given in gram and the volume is given in cm cube, so we don't have to convert the unit. Just write the formula for density. Density is represented by a Greek alphabet rho, that is equals to mass m divided by v. So mass is equals to 180 and the volume is 210. What's the answer? 100 divided by 210. What will be the density of wood here in this example? 100 and 0.85. So the density of a block of wood is 0.85 gram per centimeter cube. Now what they mention, a block is just held above the surface of the liquid which is having a density of 0.88. So there is a liquid in a container and the density of this liquid in a container is 0.88 gram per centimeter cube. And we release a block here, we just leave a block here which is having a density as we work out is 0.85. So what happened to this block? Will it float or sink? When we place the block at the surface of the liquid, the block is just held above the surface of the liquid, and we already calculated the density of a block, which is 0.85 gram per centimeter cube. So what happened to the block? Will it float or sink? The density of a block is 0.85 and the surrounding is 0.88. As you can see, the density of the block is less than the density of the surrounding density is 0.88, whereas density of the block is 0.85, so the block will float because density of the block is less than density of liquid. Is it clear? Question 3 part A and B. So it is a similar question that about the balloon. In that case, in case of balloon, the air was a surrounding, but in case of this block, water is a surrounding. Another question, a rectangular container has a base of dimension 0.12 meter multiplied by 0.16, and the container is filled with a liquid. So there's a container, a rectangular container is there, and its dimensions are given. The dimensions of the container, the sides of the container, one is 0.12, another one is 0.16 meter. The first part they ask, calculate the weight of the liquid in the container. How to get the weight of the liquid in the container? The mass of the liquid in a container is 4.8. If they do not specify a planet, so you are basically performing it on Earth. So on Earth, what there's a formula for weight. Weight is equals to mass multiplied by gravity. So mass is 4.8 and gravity on Earth is 10, so it will be 48 Newton. That is the weight of the liquid inside the container. The second part, the depth of the liquid, like it is filled with, the container is filled with a liquid and the depth is 0.32. Calculate the density. So how we can calculate the density? So as the container is filled with a liquid, and this depth is 0.32. So how we can get the volume? Because to get the density, density is mass over volume. Density is denoted by Greek alphabet rho, which is m by v. The mass of the liquid is already given, that is 4.8. But how to get the volume? The volume is length in a rectangle, length, width and height. So we have the length, which is 0.12, multiplied by width, which is 0.16, multiplied by height, that is 0.32. So what is the answer? 4 divided by the product of 0.12 into 1.16 into 0.32. The final answer for the density. Question 4 part B. So first multiply the length, width and height. Instead of doing all together, It's better you solve step by step. So how to solve step by step? So you should multiply first the 0.12 with 0.16 with 0.32. So that will give you the volume. So in this example, the volume is coming out as 0.0 0.0389. That's a volume. And mass is 4.8. So 4.8 divided by 0.03. So 0.12 times 0.16 multiplied by 0.32. Actually, that is 0.006. So this one is 0.006, and 4.8 divided by 0.006, that's approximately, or it is equals to 800 kilogram per meter cube. I did not take the complete numbers after 6. If you take the complete, then it will be approximately 780. But I took only 0.006, that's why I'm getting 800. Is it clear? Question 4, part A and B. Anyone having a doubt till now? Abdullah, Sarfraz, Abdullah Khan, Afreen, Shazib, Yusra. Any question or a doubt? Yeah, because it's in a rectangular container, so when it's a rectangle, it will be length into width into height. Like the volume of the liquid will be same as the formula of the rectangle, which is length into width into height. As the liquid occupy the space provided or given, so we can use the formula for a rectangle to work out the volume of liquid. So these are the questions related to topic density, mass and weight.